Alright, for our last problem, we're going to look at an olefin metathesis 6.27. I'm going to overly simplify this problem just because the point of action is actually just the two alkenes. So what I'm going to do is draw this, looping around as long as there's a bunch more stuff here going on, and draw another alkene like this. And the first thing I'm going to do is I'm going to number these alkenes, the carbons of the alkenes, 3 and 4. What we're going to end up with is a single alkene connecting everything together. And what's going to happen is we're going to be left with carbon, we're going to be left with carbons 1 and 4 in the final product. Okay, so the catalyst is going to do this is something called Schrock's catalyst. It's a molybdenum based catalyst. So a little MO. It has a strange looking carbon double bonded to the metal. Let me draw it a little bit better. This is called Schrock, and this stuff was won the Nobel Prize in 2009, I want to say. So let's show the first step we're going to work on. Essentially what we're going to do is the molybdenum is going to react with carbons 3 and 4. The way it's going to do that is it's going to form a cycle. A 4-membered cyclobutane ring. To form a little box. Whoops. Which we're used to from some other reactions like the Wittig reaction, if you remember that one. There's our molybdenum. There's the R group. Remember our carbons here. 3 and 4. So what we need to do is get the molybdenum attached to 4, because we know in the products here, carbon 4 is in the products, but carbon 3 is not. So we need to lose carbon 3. So if we move these electrons here, and these electrons here, we form a new double bond between molybdenum and carbon 4. And we've lost the alkene R group with carbon 3. There's carbon 2 and carbon 1. And now there's carbon 4 double bonded to molybdenum. Put the 2 and the 1 back over here too. Okay, so now we want to do the same thing we just did, form a 4-membered ring with carbon 1 and 2 we're going to attach to the molybdenum, and we know we need to make the bond between carbon 1 and 4. So this first step is we'll get there. Use this thing first is to form a 4-membered ring. And again, obviously this is an oversimplified version. The carbon 2 is now bonded to molybdenum. Carbon 1 and carbon 4 now are attached together. So to finish this off, quiet alley. We form the double bond there, and these electrons go there, and we get to the double bonded carbon 1 and 4. And the final product, sorry about that, finish it up. Our molybdenum is then double bonded to carbon 2, and it can start this little cycle all over again. Double bonded to carbon 2.